Reflection. Reflection is one of the various transformations, geometric transformations. Now, here, what we're going to look at is the fact that in order for a point to be reflected over a line, the column matrix representing the point must be multiplied by a 2 by 2 matrix, which is the reflection matrix. Now, don't try to remember these matrices unless you have an extremely good memory, right? It's not so easy to remember the right matrix for the reflection over the right line. What you're going to do is to look at various examples and look at the general case of a reflection. The first reflection we're going to look at is reflection over the x axis. So let's look at what happens when a point is reflected over the x axis. Suppose you have a point located at 5, 2. It's right here. So the point A must be reflected over 5, 2. Let's make that point. Yes, it's right there. So we want a point to be right there. This is a point. Good. So we have our point. Let's make the point. Yeah, it's blue. Let's make it remain blue. And it's that dot that we have there. It must be reflected over 5, 2. So remember, this is 2. This is 5. So it's at 5, 2. Now, if this is reflected over 5, 2, then what we'll have is that it is reflected over the x-axis. 5, 2 is reflected over the x-axis. Remember, this is the x-axis that we're looking at right here, right? That's the x-axis. Let me erase those marks. Now, the thing is, when you reflect this over the x-axis, it will come over here. You flip it right over. So the distance up to A will be the same distance down. Now A will be reflected onto a new location we'll call A prime. Alright? Now the thing is, when you do that, what you will find is that A is located at 5, 2. A prime will be located at 5, negative 2. Now, this is reflecting using a graph paper. In some cases, you're required to do the reflection using multiplication of 2 matrices and not a graph paper. And you must show how you get A to become A prime. Alright? You have to show it. Remember, A prime is right there. A is up here, A prime is here. It's obvious that from the graph that A at 5, 2 would be reflected down to 2 to 5, negative 2. Alright, it will line up below 5, A above 5, B A prime below 5, but what you'll have is the distance up to A will be the same distance down to A prime, because the x-axis here is the mirror line. All right, now the thing is, we need to have two matrices multiply so that 5 2 become 5 negative 2. The matrix representing A is 5 2. It's a column matrix. Let me draw it a little further out. This column matrix is 5 2. There's a 2 by 2 matrix that multiplies it, and the answer is 5 negative 2. Now, what could possibly be the elements in this 2 by 2 matrix, the translation matrix? Now you have to review your matrix multiplication. A number will be here, right? That multiply 5 to get 5. Let us say these numbers are A, B, C, D. We know that A times 5 plus B times 2 will be 5. Once you remember your multiplication properly, A multiplies 5, because you remember it's row by column. Alright, this row will multiply the column to get row 1, column 1. There's only one column in the answer. Now, A times 5 gives you 5. What it's suggesting here is that A would be 1. So A is 1. Now B times 2 plus 5 gives you 5. Now remember, when you multiply the matrix, let me redraw this thing here. When you multiply this matrix by this, it's 5 plus something. It's 1 by 5 plus B by 2. It gives you 5. What do you add to 5 to let 5 remain? It must be 0. That means B by 2 would be 0. So B would have to be 0. 0 times 2 gives you 0. So B must be 0. Alright. You see that? Now, C times 5 plus D by 2 gives you negative 2. Alright? Now you can see what's happening here. If you have C by 5, give you 5C plus 2D, and all of this come together to give you negative 2. Right. The 5C does not play a part. So it indicates that C times 5 will be 0. So C must be 0. So this is 0 by 5. D times 2 gives you negative 2. What it suggests is that D must be negative 1. Right? So let me erase D and put negative 1. So what you have happening over here is that you would have 0 by 5, 0 by 5 plus 2 by negative 1. So 0 by 5 is 0, 2 by negative 1 is negative 2. So this is the matrix we're looking at all along. Right? What we have is 5 negative 2. So 1 by 5 plus 0 by 2 gives you 5. 0 by 5 plus negative 1 by 2 gives you negative 2. So a reflection over the x-axis occurs from the matrix 1, 0, 0, negative 1, multiplying the point. Alright? So this is one example. Now, let's look at it in a more general sense. Let's erase what we had up here and look at it more generally. Alright? Now, if A is located at X, Y, whatever X and Y are, A is located at XY. When it's reflected over the X-axis, you expect A prime. So remember, A is at X, Y. The coordinates are X, Y. A prime would be located at same X, but negative Y. You can see if you reflect A over the X-axis, you would have the same distance from 0 above to be the same distance from 0 below. A would not shift left nor right. It would only be flipped over the X-axis. Now, it means the column matrix A, B, C, D multiplies the column matrix X, Y to give X, negative Y. Now, this is saying A times X, AX plus B times Y would give you X, as up here. C times X, so CX plus D times Y, dy, gives you negative Y. Now, C by X, A by X gives you X, so that means A must be 1. Alright? 1 times X gives you X. B by Y, there's no Y there, so B must be 0. So A is 1 and B 0. So let's make that adjustment. A is 1 and B is 0. So A becomes 1, B becomes 0. Now below here, C by X plus D by Y gives a negative Y. There's no X here, so it suggests that C is 0. So this would be 0. D times Y. Y becomes negative Y, so D would be negative 1. So C is 0. So you erase C and put 0 there. D must be negative 1. So D is negative 1. So again, you have the vector 1, 0, 0, negative 1 as a translation vector for a reflection over the x-axis. Alright? Now, here, if you have x negative y reflected, then what you would get now is x negative y is going to be multiplied by 1, 0, 0, negative 1, and what you get is xy. Right? Let me do some erasing of some of the work that I did here. Don't want the board to be too crowded. Alright, so x negative y is right here. This x negative y would be reflected over the x-axis to become x positive y. Now let's multiply the matrices. 1 by x. So what you get here is 1 by x would be x plus 0 by y, 0 by negative y. Alright, so this part will be gone and you have x at the top. 0 by x, which will be 0x. That amounts to 0, so that's gone. Plus negative 1 by negative y. Negative 1 by negative y gives you positive y. So here you have y. So here you have X at the top and with just Y alone at the bottom. So you get your your new point. All right. Let's see what happens over this side, to a point over to that side. Let's do some erasing. Let's erase these things here. All right. We have our point. What happened to the grid? Seem to have. All right. Let's put my grid and my axes. This is a point. So I don't want to have that happen. All right. Let's just erase this point here and put another point. Erase all of these marks. All right. All right. Now, let us put a point over here, a general point. Now, this is a negative X. This is negative X, negative Y. So, let's put a point over here, a green point right here. All right. Now it's located at X, negative X, negative Y. Where would it go when it's reflected over the X axis? Well, you can see that it would go up. It's 2 units below the X axis, so it would go 2 units above the X axis. And let's make this new point a red point. All right. So what we have is A here reflected to become A prime. The green point reflected over the x-axis to become the red point. The coordinates of the green point here would be negative X, negative Y. And the coordinates of the red point here would be negative X, positive Y. You can see that from the drawing. But let's use the same translation matrix to see if it would really happen. All right. So what we have is 1, 0, 0, negative 1 multiplied by negative X, negative Y. And the answer that we're looking at would be negative X positive Y. Would it really work out? Let's multiply them. 1, when we multiply the matrices, you get 1 times X would be negative X plus 0 times negative Y, 0 by negative Y. Then we have 0 by X, which is 0 by negative X, right? Plus negative 1 by negative Y is minus 1 minus Y. Now negative X, this would be negative X plus 0, which would be negative X, because 0 by negative Y is just 0. 0 by negative X here is 0. Negative 1 by negative Y would be positive Y. So it does work. Alright? So the green is reflected up to the red. Now let's reflect the red down to the green and see how this part would work out. What we have is the red point reflected over to the green point. So we imagine that what we have here is our A point A here is reflected down to A prime, and this is A prime. Now the coordinates of A are negative x positive y, as you can see here. So we have negative x positive y. When we multiply by the translation matrix, it becomes negative x negative y. Now let's do the multiplication and see if it really would work that way. So what we have is 1 times negative x is 1 by negative x plus 0 by y, 0 by y. And here we have 0 by negative x, 0 by negative x plus negative 1 by y, negative 1 by y. Now, what matrix would that give us? The matrix that would give us, is it going to be negative x negative y? Let's see. 1 by negative x is negative x plus 0 by y, but that's 0, so we can leave it off. 0 by negative x, that's 0, so we leave that out. Then we have negative 1 times y gives you negative y. Okay, so it does work. So this matrix 1 0 0 negative 1, it always reflects a point over the x-axis. And if we have a line with 2 points, we do it on each. But if we have the triangle having 2 points, we perform that transformation on each. Now let's do a more specific example. All right, let's do a more specific example here. Now we have the triangle ABC, and the triangle ABC is such that A is at 1 1, so A is at 1 1. All right, so we have A here. B is at 5 1, no 5 2, so 5 2 is right here, and C is at 4 6, so we have 4 6, 4 6 right here. We're not going to write in the ABC as we don't want to crowd the diagram, the screen too much. All right, so we have these points. Let's draw a triangle there. All right, so we have 1 1 right here, 5 2 is 5 2 right here, 4 6 is right here, and we close the polygon, which is our triangle. So that's our triangle. Let us now make some adjustments. Let's make the sides of our triangle thicker than they are right now, so we can see them. So we start with this triangle, which is really a dark red color triangle, right? And we make the sides quite thick. Now when it's reflected over the x-axis, we multiply each matrix by 1 0 0 1. Let's do the multiplication. We have 1 0 0 1 multiplied by 1 1. Now here, when we multiply them, we have 1 by 1 is 1 plus 0 by 1 is 0. we have 1 by 0 is 0 plus 1 by 1 is 1, right? Negative 1, I mean 1 0 0 negative 1. 0 by 1 is 0 plus negative 1 by 1 is negative 1. So what we get here will amount to 1 plus 0, which is 1, 0 plus negative 1, which is negative 1. So that's what we have. Alright? So we have 1, negative 1 as our new point. So A prime will be 1, negative 1. What will B prime be? If we take B and multiply it, what we'll get is B is 5, 2, multiplied by this, 1 by 5 is 5, plus 0 by 2 is 0, okay, 0 by 5 is 0, plus negative 2, negative 1 by 2 is negative 2, so it's 5, negative 2, and C is 4, 6, we're going to multiply by 4, 6, so we have 4, 6, 1 by 4 is 4, plus 0 by 6 is 0, 0 by 4 is 0, we don't have to write it, plus negative 1 by 6, negative 6, so it's 4, negative 6, right? So let's draw our new triangle and see what it would look like. We have 1, negative 1, first point is here, 5, negative 2, we go to 5, negative 2, that's right here. The third point is 4, negative 6, so we add 4 and negative 6 right here, and let's close it. Alright, so there we have our new triangle. Let us make some adjustments to the size of the sides, and let's make the sides a bluish color. Right, so what we're going to do, select the size of the triangle and make our adjustments. Make it blue and thick. Good. Our new triangle, make it thick and the color blue. Nice. And this one, make it thicker and make the color the same blue as before. So there we have it, and you can see that if we reflect 1 over the x-axis, it comes here, B over the x-axis it comes here, and C over the x-axis it comes here. Alright, so that's what we have, reflection over the x-axis.